4.7. Scientific notation. You've done scientific notation before.
I don't remember.
I know. We'll review. It's really easy.
Did we learn it in science?
You learned it in science last year.
I think that's why it's called science.
And you also did it in 7th grade math a little bit, and probably earlier math than that. But scientific notation all involves exponents. That's why it's in this whole section, because it involves exponents. Okay. So. I'm going to come back to this in a minute. We're going to start here first. Okay, scientific notation.
Holy shalupa.
Scientific notation is written in the form of a constant, that's what the C stands for, a constant times 10 to an n power, a number. It stands for a number. Okay, where 1 is less than or equal to C and C is less than or equal to 10.
I'm confused already.
So your constant has to be greater than 1 and less than 10.
10.
That's what that says.
This sounds like an equation.
2, 3, 4, 5.
Yes. So to write something in scientific notation, I have to have like 2.6. That could be part of scientific notation. Time out. Listen first. Just take it
I'm
in.
going to ask you to explain.
I am. Just give me a second. That's what I'm working on. What?
Is it possible for a fraction to be the...
No, it's going to be in decimal form, not in fraction form. Okay. So, scientific notation, this constant right here has to be a number between 1 and 10, Jacob. 1 and 10.
Oh, I see.
Okay, so I can't have like 14 there, and I can't have like a half or negative 1. Yeah.
Do you know it has to be between 1 and 10 because there's 10 right there?
Because in scientific notation, I'm counting decimal places. And remember how the first decimal place is what? What is that? 1, 10.
10.
And then 1 100th, and then 1 1,000, and so on and so forth. Okay? So we're counting technically by 10. We're multiplying by tens. Does that make sense, what we're doing there?
Yeah.
Okay? So that's why everything has to
So
go
no matter what, it's got to
around.
be between 1 and 10 no matter what the equation is?
Right.
Are you okay?
Okay? Now, standard form, stop. There are 3 different types of forms when we're talking about how we can write things. Some stuff is in standard form, where I just write a number the normal way it is, okay? So 725,000 or 0.006, this is standard form. That's just how I would represent a number normally, okay? The next part is called product form. Now, in product form, it's different than scientific notation because of this. Do you see how I took 7.25 from this 725,000 and I'm multiplying it by 100,000, okay? So I'm multiplying it by 100,000 to get it back up to this. So I turned it into a decimal number that's between 1 and 10, but I'm multiplying it by the full 100,000. Whereas in scientific notation, I multiply it by 10 to a placeholder of 5 because I have 5 zeros. What?
Do you always multiply by 100?
No. When it's in product form, you're multiplying by what it takes to get that whole number there. So or to get that number that's between 1 and 10 there. So I had 725,000, I had 0.006, yes? So in product form, I changed this to 7.25, a number between 1 and 10. What do I multiply 7.25 by to get it to 725,000? 100,000. What do I multiply 6 by to get it to 0.006? 0.001. Okay, does that make sense? That's product form. Then we take product form one more step, and that's where we get scientific notation. So scientific notation is product form without this portion here. We're going to change it into a base of 10. So I have 7.25, okay, because that's a number between 1 and 10. I changed this. I moved my decimal 1, 2, 3, 4, 5 spots, yes? So I have 7.25 times 10 to the 5th because I moved my decimal place 5 times.
To answer a problem, we got to write all that down.
No. To answer the problem, you're doing it this way. I was just showing you the steps it takes to get there so that you can visually see what I'm actually doing.
So like,
I feel like something's
this,
Stop.
the bottom one goes to the top one?
The bottom one is this written in scientific notation.
So,
The middle one is this written in product form.
So is like the question going to be like the standard form and then say like...
Yes, write it in scientific notation, or it's going to give you scientific notation and say, write it in standard form. Okay? Yes, E.
Can I
Yes.
No.
Thank you.
Okay, now look. Here's the trick about this. Here's the trick. Do you see in standard form how 0.006 right here, if I move this decimal place 3 spots, I get 6. So I have 6 times 10 to the negative 3. Now listen, when you move to the right, your decimal to the right,
To the right.
okay,
to the
you
right.
get negative exponents. When you
Right,
move it to
negative.
the left, you get positive exponents, which is opposite of how we think because of the XY coordinate system, yes? Okay,
That's-
so it's
I-
opposite of how we think. We usually think to the left is negative, to the right is positive. It's opposite. I am going backwards in this case. Okay? In this case, I'm going forward.
Yeah, thought so.
So if you have this number, basically, if I have a decimal, or if I have a smaller number going to a larger number down here, I'm going to have negative exponents. If I have a large number going to a smaller number here, I'm going to have positive exponents. That's how I remember it, okay? So if you have a small number going to a large number, you have negative exponents. If you have a large number going to a small number, you have positive
If
exponents.
you have the number 5 and the Sunday, somehow by God, that thing turned to 5,000. It's now negative.
Yes, because I multiplied it by 10 to the negative whatever. Yes.
Okay.
Okay.
I understand now.
Okay.
Probably.
So then we're going to read this green thing because it goes with this blue stuff. Okay.
You stop.
It says,
What's your problem, Marshall? What's up?
turn around, Marshall. Turn around.
Can't focus. They're over there making so much noise.
Ain't nobody making no noise.
Actually, they're really not making noise today. Relax. Calm down. Josh, keep your mouth closed a little bit more. Okay.
It kind of feels different now, Brian.
Okay. The retina,
Oh, wait,
is
Brian's
a
not
layer.
here.
Stop. Jacob, focus. You're doing good so far. The retina is a layer of the eyeball that contains rods and cones. Rods and cones. Rods and cones are cells that absorb light and change it to electric signals that are sent to your brain. The human retina is about 0.00012 meter thick and contains about 120 million rods and about 6 million cones. Okay? The retina has 120 million rods. Write that in scientific notation.
600. What? What?
Wait,
12 million?
How would I write that in scientific notation?
Oh, I think I know this. I
Okay,
think I
wait.
know this.
What's your question first, Emma?
Since you have to. Okay, so on the thing that we just did,
Yes.
there's like 2 standard form numbers, right?
This is a standard form of a large number. This is a standard form of a decimal.
Yeah, and there's 3 in the word number, so I don't know.
It's okay. We're focusing on just one right now. Focus just on this.
Oh.
Okay.
1.2.
So you're gonna change it to what?
1.2.
Okay, I'm gonna change it to 1.2.
Oh, I thought I said 120.
No, I want to change it. You remember your number has to be
Oh,
between
yeah, that's
1
right.
and
That's
10.
right. You're right. Okay.
So how
hold
many
on.
times did I move that decimal?
1, 2, 3, 4, 5, 6, 7, 8.
11,
9, 8. Yeah, 8.
Times 10 to the 8. Is that
Oh,
what
my
we're
God.
going to? 10 to the 8. Okay, question. That is correct. So I get 1.2 times 10 to the 8. Remember that your constant has to be a number between 1 and 10. Okay, 1 and 10. That's why we changed it to 1.2. Now, it says write 0.00012 in scientific notation. Okay, Carter, what?
Is it 1.2 times 10 to the negative?
Negative what? That's too many numbers for me.
Times 10 to the negative what?
4?
But it doesn't go over 10 times.
Yes, times 10 to the negative 4.
1, 2,
Remember, we talked about how the 10 is represents the 1/10, 1/100, 1/1000.
Oh, yeah.
What?
Negative goes that way.
Yes.
So it's
Yeah,
negative.
that way.
So like just move 1, it's negative 1.
Yeah.
Yes.
To the right.
Yes.
To the left is positive.
Yes.
Okay, that makes sense.
Yes. Okay. So there are those 2 numbers written in scientific notation. I am not done. I need you to focus.
You have the why you keep looking at me?
Stop. Stop.
No, I'm like,
Yes, Carter, what?
which one do you reckon?
Oh, we're going to let somebody else do this one. Okay. Write 3.2 4.2 times 10 to the 7th in standard form. Now I want to write it in standard form. How do I do that?
Is this the one?
Wait.
Move it to the right 7
No.
times.
You move it what?
To the right 7 times.
To the right 7 times. Beautiful. If I move it to the right 7 times, how many zeros am I adding?
6.
that-
6.
Good. 6.
We're so good.
Hey, I'm smart.
And then I can come back and put my commas in so that I know what number it is. So it is 32 million. Okay? Now, how do I write 8.69 times 10 to the negative 5th in standard form?
You have 6.
Put it to the
Right.
left.
You move it.
Move it to the
Right.
Oh, so you move to the left. Go to the left. To the left.
You
move
move
it
it the
or
left.
this way.
That's right. I was wrong.
Okay, I move it to the left. I move it to the left. But how many zeros am I going to add in?
6.
4.
4. 4.
I'm at 4.
4.
I'll
So I'm
stick
going
to
to say
4. Like, my mouth says 6.
You gotta stay 4.
4.
Stop.
4.
So I get that number. Because here's why. I have to move this decimal place once before it hits past that 8 in the first place. And how many times am I moving it total?
Oh, okay, got it.
Does that make sense? So always take in consideration that 1 or 2 that you have to move it, okay?
How did I get this?
Because you're smart.
No, I mean this pencil. It just showed up on the paper. Did it not?
Quickly. Okay, order.
I don't know where it's been though.
Hey, I need your attention. We have 2 more problems. Stop throwing things. Josh, focus. Put that away. You don't need it out. Close the computer.
That's just here talking.
Okay. Order 3.9 times 10 to the 6th, 3,800,000, and 4.2 times 10 to the 5th from least to greatest. What do you want to do first to see what order to put this in?
Least to
Put
greatest.
'em- good. Jason had a great idea. He says put them all in one form. 2 of them are already in scientific notation. What do you think I probably should put the other one in then? Is it easier to change 1 or change 2? 1.
1.
Okay, so let's change this one. If I change this one, what do you change this to?
Is it 3.8?
3.8.
10 to the 10 to the
1, 2,
6.
3,
10
4,
to the
5,
6.
7.
6.
6.
7. What?
1,
No,
2,
wait.
3, 4, 5, 6. Okay, so I have 3.8 times
Oh,
10
I
to the
counted
6th.
1 too many zeros.
I have 3.9 times 10 to the 6th. And I have 4.2 times 10 to the 5th. Which is the least?
3.8 times 10.
3.8.
You got
3 point. What's the least or the most?
What is the least?
3.8.
3.8.
Boom.
No.
Time out. Stop.
Times.
Wait. No. Wait.
Stop yelling.
There you go.
What?
It would be 4.2.
Why would it be 4.2, Emma?
Because
Oh,
stop multiplying it like another time.
Because this only has to the 5th power, which means I'm only adding 4 zeros,
Oh,
right?
you're right.
So least is 4.2 times 10 to the 5th. What's the next? What's the middle?
3.8
Times-
10 to the 6th.
Good. 3.8 because 3.8 is smaller than 3.9. And then I have 3.9 times 10 to the 9th, or 10 to the 6th. Okay, beautiful. So that's from least to greatest. So on your homework, you are working on taking word problems and changing numbers in word problems to scientific notation. Okay, you're going to work on taking standard form or product form and turning it into scientific notation. And you're going to work on taking scientific notation and undoing it into standard form. Then you're going to order things from least to greatest. We have one more problem and then we're done. What?
I'm so confused on that word problem. What did we need with the 6 months?
All they wanted, we didn't need anything with it. It was useless information. Yes. Okay. Last word problem, then we're done. I guess you call this a
Oh.
Wolfia plant. Is the smallest flowering plant in the
That
world.
gotta be German.
A Wolfia plant has a mass of about 1.5 times 10 to the negative 4 of a gram. At least 5 times 10 to the 3 Wolfia plants could fit in a thimble. Do you know what a thimble is?
Like,
Yes,
isn't that the
it's-
thing that Peter Pan gave?
Yes, it goes over your thumb when you sew. So that
Isn't
you,
that isn't the thing that Peter Pan gave Wendy?
yes,
What?
yes,
Yes.
yes.
Oh.
Okay.
The thing that Peter Pan gave.
What?
Then it's the thing that Monopoly.
That what?
Yeah, I have a monopoly piece.
Oh yes, they do have a thimble in my home. What is the mass of 5 times 10 to the 3rd Wolfia plant? They want to know what is the mass of 5 times 10 to the 3rd
Should I what?
How do
5
I do that?
Oh, it's 500.
I got it rolling.
Wait, no, it's 5,000.
Right now.
5,000.
What do I do? What do I do? Okay, listen. They want to know what the total mass of the plant is, yes?
Yes.
Yes.
Okay, what do you think we do, Carter?
Did you
Oh
add
my god.
1.5 times 10 to the negative
Yeah,
4
it's
times 5
Guys, I can't hear Carter. Would I add them? I want to add them.
would you add 1.5 times 10 to the negative 4th and then 5 times 10 to the 3rd?
I'm not adding them.
Oh,
I'm multiplying them. I'm multiplying them. So I take 1.5, stop talking. Kate and Emma.
1.5.
So I'm going to take 1.5 times 10 to the negative 4th and I'm multiplying it by 5 times 10 cubed because I'm trying to figure out the mass. And the mass is the mass of the plant times the number of plants. Okay? If I do that,
Wow.
Right.
if I do that,
Today.
how do I do that? What do I need to do now?
You gotta like find them individually.
Okay, what does that mean individually?
Like,
You're on the right
you
track.
gotta do like 1.5 times the thing by itself, and you do like 5. Like you put it both in standard form.
Okay, look. What I'm going to do is I'm going to take these numbers and multiply them together.
Oh, I was way off.
1.5 times 5.
This
And I'm going to take this and multiply it by this.
multiply.
10 to the negative 4th times 10 cubed. Now listen. I have to do that because I'm multiplying both of those units together. And remember, I can only multiply things with the same base when there's powers.
Yeah, like that one thing we learned.
So what is 1.5 times 5?
That is
25.1.
No.
7.5.
It's 7.5. Okay? It's 7.5. What is 10 to the negative 4th times 10 to the 3rd?
10 to the negative
100.
10 to the negative 1st because you add exponents and you multiply them.
10,000. No.
Wait, what is it?
What?
Okay, so
How?
You add exponents.
so I can leave it in this form, okay?
Oh, yeah.
I have answered my question. Or if I asked you what this is, stop. If I asked you what this is in standard form, what would you tell me? Someone besides Carter, what would you
I
tell me?
would say that is 0.75.
0.75.
Hey.
Hey.
You're going to have to be able to do that on your homework.